Okay, first of all, this is our second block on B day notes. So if you're the first block on B day, you already had these and they're in a different order. So you can fast forward past this part. Um, so for our first block though, we want to make these other identities. So based on our first Pythagorean identity, we're going to solve it for cotangent squared. So what I mean is we're going to subtract 1 off both sides of the equation. So that would give me on the left side cotangent squared of theta equals, and then on the right side I have cosecant squared of theta minus 1. And that's going to be another identity that we can use. Now we're going to solve for 1. So if I want to get 1 by itself, I'm going to subtract cotangent squared on both sides of the equation, okay? And what's the resulting identity we get from that? We get 1 equals cosecant squared theta minus cotangent squared theta. We're going to do the same thing here with our cosine squared plus sine squared equals 1. We're going to solve it for cosine squared by subtracting sine squared off both sides. And we'll get different identities. So cosine squared is equal to 1 minus sine squared of theta. If I subtract sine squared off both sides. Now I'll solve for sine squared. So sine squared theta is going to be equal to 1 minus cosine squared theta. And then I'm going to do the same thing here. So I'll solve for tangent squared. Tangent squared theta is going to be equal to secant squared of theta minus 1. And then I'm gonna solve for 1. So I've got 1 equals secant squared theta minus tan squared theta. Now what you're going to want to do is you're going to want to write down these strategies that we have. So you can pause the video here and write down our strategies. All right, so you should have those written down. And we're going to do some examples, like probably 2 or 3 examples here. And then when we come to class, we'll start doing some practice. The first example, we're going to have sine, what is it going to be? Sine of x cotangent of x. Sine of x times cotangent of x times secant of x equals 1. So there's no squares here. I know I see the 1 over here, but there is no squares. So we're not going to do our first strategy, which says if we see like trig squared in 1s, we're going to use Pythagorean. So now we're going to go to strategy 2, write everything in terms of sine and cosine. And then do some algebra simplification. So I've got sine times cotangent is cosine over sine times 1 over cosine, because that's secant, equals 1. So then if we multiply these fractions out, I would have sine times cosine in the numerator and sine times cosine in the denominator. And then anything divided by itself is 1, so that's been verified. Another thing we can do is we can do this division when it's multiplication of fractions. Not for addition, but multiplication. I can do this division here first. Sine divided by sine is 1, and then 1 times all this other stuff doesn't change it. So then also cosine divided by cosine makes 1 as well. So there's our first example, and we verified by using strategy number 2. All right, let's look at a second example here. Sorry. So we're going to do sine of A over cosine of A times tangent of A. And that's also going to be equal to 1. So with this one, again, there's no trig squareds or anything. So I'm going to say that there's no Pythagorean identities right away. So we're going to change everything to sine and cosines. So we've got in the numerator sine of A. I should be putting all my angles in parentheses, sorry. Sine of A over cosine of A times sine of A over cosine of A. So I'm changing tangent into sine over cosine. In the denominator, I'm going to look at this part here, and I'm going to multiply those fractions together. So I've got sine of A times cosine of A all over cosine of A. Now that's just in my denominator, so actually I didn't leave myself enough room. In my numerator, I still have my sine of A, and it's equal to 1. So what I notice here again is cosine divided by cosine is just 1. So now I have sine of A over sine of A times 1, which is just sine of A. Then I notice here sine of A divides out. Sine of A over sine of A is 1, and so I have 1 equals 1, and it's verified. Or I should say verified, not verified. Okay, we'll do one more example. Let's take a look here. Let's do secant of B minus sine of B times tangent of B equals cosine of B. So I kind of ran into this other one. All right, so once again, I don't see any trig squared. So I'm going to change everything to sine and cosine and try to do some algebra. So secant is going to be 1 over cosine of B minus sine of B times tangent is sine over cosine, and equals cosine of B. And I want to make the two sides equal to verify. So what I'm going to do here is I'm going to start by multiplying these two fractions together, because then I also have this subtraction here. I'll deal with that later, but let's do the multiplication first. Sine times sine in the numerator gives me sine squared. And 1 times cosine gives me cosine. All right, so now that I want to deal with the subtraction, to subtract these fractions, they need to have the same denominator, and they actually do. So that's good. So my common denominator is cosine B, so that's going to be the denominator of my new fraction, cosine of B. In the numerator, I go 1 minus sine squared of B. And then here's where I start to think, okay, I've got a trig squared, I've got a 1 involved. This might be a Pythagorean identity. 1 minus sine squared. Let me see if I have that anywhere. So if I look back up here, I see like, oh, yeah, right here, 1 minus sine squared is also equal to cosine squared. So I can take out the 1 minus sine squared, and I can replace it with cosine squared. And now lastly, I have cosine squared divided by cosine would just be cosine. So it's verified. All right, and then we'll do some practice in class next week.